You're listening to Made for IoT, a podcast celebrating the leaders, innovators, and disruptors of the Internet of Things, from hardware to connectivity to cloud. For more insights, make sure you visit onomondo.com.
Okay, hello everybody. Welcome to this webinar together with Martin from Nordic Semiconductor. We'll be diving a little bit in today on the low power IoT use cases and some of the innovations that Onomondo and Nordic Semiconductor have done together on this front recently, and also see a bit of a test on just the progress that we've been making. So that should be really exciting. I'll just tee up this presentation here. Today, as said, we'll dive into some of the, especially on the power saving side of the combination of Nordic Semiconductor's nRF91 series and SoftSIM from Onomondo. Together with Martin, I'm gonna try and guide us through the first part a little bit, and then Martin will dive in on some really cool material from Nordic. Martin, maybe if you'd like to just introduce yourself briefly, that would be great.
Yeah, thank you, Michael. My name is Martin Lesund. I'm a technical marketing manager for cellular IoT, and I work at Nordic Semiconductor, and we have our main headquarters in Trondheim, and now it's winter time and quite cold here, so I'm excited to get started about this webinar. Thank you.
Good. Yeah, I feel like we've got a bit of wind from the north recently. So we're based in Copenhagen. My name is Michael. I'm the co-founder and CEO of Onomondo. And just as a maybe a preamble here, so Onomondo, we are a sort of a networking and technology stack for IoT. We are a cellular network globally, and then we also operate sort of across the stack into a bunch of software that we think is necessary for driving really optimal use cases for IoT. One of them we'll go through today, so that should be really good. Cool. So we got 4 items on the agenda today. I'll just briefly maybe just introduce a little bit into SoftSIM, what we've done here, what we've set out to achieve with this. Then some of the benefits, obviously, especially maybe connecting the dots over into Martin's segment, which is going to go into the power consumption test, which is the sort of the main headline of today. Really trying to reap the benefits of these this SIM and module coming together in a really cool way. So that's the meat of today. And then of course we have a little bit of a slot at the end for Q&A. If there's any questions along the way, please feel free to write them as we go in the chat. Maybe we can address some of them on the way, but otherwise we have a good slot at the end for that. And any questions that we might not get around to will be answered afterwards. You will be contacted with proper answers for those. So please go ahead and just ask away. Cool. So without further ado, what is SoftSIM? Maybe we should start there. So SoftSIM is really as the name suggests, a software version of a SIM. So the SIM, of course, is a you can say a connection to the network. It's what connects the hardware to being able to connect to a network, and it's been around for ages, you can say. What we set out to achieve here was really understand better how we could optimize the SIM itself. Nobody wakes up and thinks of a SIM in the morning, but everybody probably thinks more about what it's supposed to achieve. And so the mission here was really how can we optimize what the SIM is representing as a cost to this device and to the solution as a whole, without losing any of the benefits. And so some of these benefits, of course, go into cost savings. If you remove hardware, typically it becomes a cost optimizer too. There's the whole forecasting and deployment and provisioning aspect of things where we can virtualize some of these things. Then there's the power savings, which Martin will dive deeper into in a minute, but which is a huge benefactor from this as we remove a lot of overhead around the SIM itself. And then maybe translating into smaller devices or longer lifetimes or sort of those sort of things. And we wanted to attack that from a software angle and then really use some of the aspects that are already present on devices today. And we'll surely get to that in a minute. And maybe just to set the landscape here, what is a SIM really? So SIM cards and chips have been around forever, you can say. They really consist of a separate little virtual machine, a little computer in itself, consisting of hardware, the chip, the SIM card, you can say, and the chip on those. And then there's the sort of overhead of software supporting that, so the operating system, the file system, and so on. And then you have the SIM application itself. And what we set out to do is really reap the benefits of this processing power and secure space that already sits on modern hardware, and simply separate out the SIM application and put that in a safe place on the hardware that was already there to reap those benefits of removing that overhead. And essentially, that is what it is. It's a SIM without the hardware, so it's a software SIM. And if you look at sort of a little bit of a history lesson, not too much, hopefully, but just over the evolution of the SIM itself, this is sort of the miniaturization journey, you can say, of where things have gone. Starting, of course, way back in the day with the 1FF, 2FF, etc., then translating in sort of the IoT age into MFF2s, MFF XS chips, which are slightly smaller, and then even smaller iSIM. Some of these, most of these, are modem agnostic. iSIM is you can say typically the one that will come closest to being a integrated SIM, but it's still a dedicated hardware piece that sits on the modem, and so it becomes modem dependent on the integration of this hardware, right? SoftSIM is trying to bridge the gap there, so it is a modem agnostic piece of software that lives on the device without having any kind of or dependent on hardware of any kind. And so it becomes a modem agnostic solution as well, but purely virtualized. We're deploying here and demonstrating today with Nordic Semiconductor, of course, because Nordic Semiconductor is sort of our first commercial partnership that we have live with the SoftSIM, and also because Nordic has this historic big focus as well on power savings, which makes this partnership really shine, and these benefits really come to full potential. But going forward, if you're using a different module or have a sort of a scattered landscape of different devices, please follow along, and we'll also sort of propagate into other parts of the ecosystem in the months to come. From a benefit perspective, you can say there's quite a few. There's of course the savings of reducing the SIM overhead costs. It goes without saying that you virtualize these things, as you miniaturize them, you minimize dependency. That also translates into dependency of other aspects of the device itself. As we minimize the power budget, that can translate into smaller batteries, less power needed for the same lifetime, or a longer lifetime of the asset, and increasing the value of that same asset. There's a ton of possibilities around making a more agile solution with both in terms of production and also over the air over time, where if something needs updating, this solution is pre-prepped for supporting those things as well over the air. And then, of course, there's the reduced footprint of also both limiting the hurdles of shipping SIM chips or cards around and making those things go into your product itself, but also the footprint around that, of course, that sits in there. but I'll maybe save the power saving wow for Martin here, as that is today's main topic. So the combined savings here is really a story of much beauty, you can say, in a way that these two focus areas of Nordic from the hardware side and Onomondo from the SoftSIM side, both doing a lot of work separately and now together on saving power for devices, making them more efficient, smaller, more agile, and more stable over a long period of time, which is really where a lot of IoT solutions could benefit, I think. So I think just to some headlines going in and queuing up for Martin here. So the nRF91 series and SoftSIM combination is commercially available today. We think this is probably the ultimate low power IoT setup that you can come across. Martin will demonstrate in a minute, but really also simplifying both hardware design, device design, and of course addressing some hardware costs on separate modules and so on. But then today also we have the pleasure of sort of revealing a power test we did with 15 major SIM providers and combinations of network providers as well. So without further ado, Martin, will you take over? Oh, sorry, I'll let you tee into that.
Thank you, Michael. So first off, I want to just touch upon what Nordic Semiconductor do and what we actually make. So we are a fabless semiconductor company. We design a low power wireless solution, basically small microcontrollers with radios, and we focus on the low power aspect. We have solutions for Bluetooth Low Energy, Thread, Zigbee, Matter, Wi-Fi, and of course cellular with the LTM and NB-IoT. So we don't only provide the hardware, we also provide free tools and software SDKs for our customers so they can develop their applications on the devices. And our headquarters are in Trondheim. So what kind of differentiates our cellular solution compared to other cellular solutions on the market? So on the left-hand side, you can see an example of a traditional cellular modem, which typically uses a chipset from another vendor in most cases, where they put their own kind of closed firmware on top of that and sell that as a modem. And users interact with that modem using 80 commands. So you would need an external host to actually drive this communication. So then you would need an external host microcontroller from maybe another supplier. And if you need to store credentials or some important keys, you would need a secure element, maybe another hardware on your design. And to power all these different chips on your device, you would use a power management IC. So then there you have another device that you need in your design. So what we did with the 9160 and the upcoming 9161 coming next year was basically putting everything in one device. And what's special with our device is that we have created our own chipset. It's entirely made by Nordic Semiconductor, and we provide the open application processor. So this is a M33 ARM Cortex processor, which also have ARM Trust Zone, which means you can have a non-secure storage and a secure storage. And that's where the SoftSIM is actually running in the secure area of the application processor. And you also have 1 megabyte of flash, 256K of RAM in the application processor for the user to actually run their applications. So that means you can have one device to do everything for the user. And we also include our own power management IC on the devices itself and also the RF front end. And this means we can actually optimize for power consumption from the back up, because we have built everything from the ground up to be low power consumption. And we also provide new updates on the modem firmware and also on the SDK to improve this with new features and also nice optimized algorithms to help on power consumption. So comparing to other vendors, we have the lowest power consumption of a total cellular IoT device on the market. So that's one of the benefits with our device. But we don't stop there. We don't only provide the hardware, we provide everything around so the developer can get fast time to market. And we provide the extensive, unique SDK, so a software development kit, which is the same for all of our devices. So you use one SDK to create application with all of our devices. So you can combine a cellular device with a Bluetooth low energy device to make a gateway, for example, and use the same SDK. And we provide the extensive software and also hardware tools and world-class support with our interactive learning platform and our support forum. And of course, extensive partner program where Onomondo is part of that because they create a big benefit for our customers with their solutions. And of course, we have life cycle services through our nRF Cloud, which is very important for devices that are going to stay in the field for 10 to 15 years, where you need firmware updates or location services, etc. But now over to the technical part around power consumption. So in cellular IoT, you have two main known cellular power saving techniques. And one of them is power saving mode, and the other one is eDRX. You have some other options as well, but for this presentation, I'm going to talk mostly about eDRX because it's really an extended DRX where you get the benefit of using a SoftSIM. So in this graph here, you actually see a kind of typical LTE event where the device sends some data in the beginning, stays in RC connected mode, and then the modem goes into RC idle. And in this RC idle mode, you can actually use eDRX to have the device wake up and listen to the network if there's some incoming messages or any pings. And then if there isn't anything, it will go back to idle and do another cycle again to see if there's something incoming. And you can request this timer for a network depending on the latency you want to have on your application and also the power saving you would get when you extend this interval. And if you want to save even more current consumption, you can use power saving mode. And this means that the device goes into deep sleep and do not wake up to listen to the network. It actually stays synchronized with the network. In the case when the device wakes up, it will not need to renegotiate with the network and set up a new connection. It will still be registered to the network. And this is usable for devices that are going to sleep for a long time, and you have, for example, an alarm, then you can wake up and send some data. The device is not reachable when in power saving mode. So if you need to have the opportunity to reach your device from the network, you would use eDRX in most cases. You can use either or combine these two techniques for saving power consumption. And this picture here just takes it one step further to look into the details of the things. We start with the network and SIM synchronization when the device wakes up and try to connect to the network. You do a RC setup for the first time with the network to set up the connection. And in this example, we just send a small packet of UDP packet of 64 kilobytes. And then it will go to RC idle mode after that. But in between RC idle mode, it needs to stay in this RC inactivity timer where you have something called CDRX, connected DRX. And this can be short or long depending on the network you're on. This is dependent on the network. And for this LTE event, you can actually see that takes 60% of the whole complete charge of the event itself. So it's a big part of this event. And after that, you go into eDRX, which is dependent on what you put at the active timer. So you can request to have a long timer or a short timer depending on the latency that you want in your device. But it's actually in this CDRX events and IDRX events where you get the benefits from using a soft SIM. Because in between these spikes, the SIM card itself need to stay in something called clock stop mode. This is typical for physical SIM cards, and SIM cards was not designed to be low power in the beginning. They were meant to be used for cell phone with big batteries, but when you're using IoT devices that needs and that are very constrained on battery life, and you want to have as long battery life as possible, physical SIM cards really hurts the power consumption. Because our device itself, the 9160, for example, use 2.7 microamps in power saving mode, while a SIM card is only required to use under 100 microamps. So that's tenfold of the current consumption. So you can imagine that you're just burning a lot of current consumption with using a physical SIM cards in these events here. And that's something we have tested with different SIM cards, also the soft SIM. So what we did was to take a 9160 development kit, and we measured with the power profiling kit 2 while running a UDP sample in our SDK. So this is open, so anyone can reuse this and test this themselves. But we measure the SIM cards in this clock stop mode, in between the CDRX events and also the EDRX events. And we can see that for physical SIMs, you get a huge current consumption average in both these events compared to a soft SIM. So we tried many different operators, and they vary differently depending on the operator. And our operator can also use different vendors for their physical SIM cards, so they can have differences between the SIM cards that they provide. So it makes things a bit complicated, as you would imagine. So in the worst case we found was this operator J at the bottom here with 57 microamps for CDRX average current, and also 60 microamps for IDRX average current. While for the soft SIM, you get only 4 microamps in CDRX events average, and also 3.3 microamps in the EDRX average. So that's a big difference if you are going to have a device that stays often in this RC idle mode. You will save a lot of current consumption, and you can extend the battery life many times. So just some key takeaways from our measurements here is that if you're developing an application, let's say an asset tracker or a smart meter that will stay in this RC idle mode for a long time using EDRX as a power saving technique, you will save a lot of current consumption using a soft SIM compared to a physical SIM. You can extend the battery life 4 to 6 times depending on your applications and how often you are in this RC idle mode. So that means you can either have lower battery cost or even smaller size compared to using a physical SIM. So that means you get a more sustainable product. So yeah, at the end here, I want to show a video that we did with a demonstration of the live measurements. And after that, Michael will take over and do some key takeaways.
In nRF Connect SDK version 2.5, we introduced the software SIM interface through our modem library for the first time, which means that you can run software SIMs on our nRF91 series. The first company to support this feature on our devices is Onomondo. Their soft SIM solution is now commercially available, and anyone that wants to test this can do it now. Just Google nRF9160 soft SIM, and the top page should bring you to Onomondo's landing page. There you can get a free trial of the soft SIM and read the guide on how to initialize it on our nRF91 series. We are now going to look at a quick comparison of running a UDP sample on our nRF91 60DK, where the device will wake up, send a UDP packet, and then the modem goes into RC idle mode, and then into extended DRX intervals listening to the network. It's in EDRX where we really see the benefits of using a soft SIM. Let's look at the measurements when using a physical SIM card. It is in between these EDRX intervals where the physical SIM goes into something called clock stop mode. For physical SIMs, they can use quite a lot of current consumption in this idle mode. We can see that the average current consumption between the paging time windows are 60 microamps. Let's now test with Onomondo's SoftSIM. Here we can see a big difference between the paging time windows. Now we can see that the average current consumption is 4.4 microamps. That is a 92% reduction in current consumption when using a SoftSIM. Whether you're looking into reducing cost, size of the final design, or reducing power consumption, try out a software-based SIM in your next nRF91 project.
Thanks a lot, Martin. So key takeaways, just to wrap things up before we go into to Q&A. So as Martin pointed out, we've done quite a bit of testing here on the combination of Nordic's ability to really be power mindful and as well on the SoftSIM side here. We believe this is really an enabler of a lot of miniaturization or stability improvements for many different kind of use cases. Typically, the ones with longer lifetimes and more efficiency requiring use cases. And as we also started out. The SoftSIM here and the combination with Nordic is commercially available today. We will enable more and more chipsets and designs and vendors on this solution. And so, if you want to stay updated on that, you can. There will be a little bit of a pop-up, and you can sign up for news as that work is ongoing. But today we think this is really a cool combination of two companies really focusing on the same thing here and have achieved quite a significant step in that regard. So I think we've reached close to the end. So I see that there's a few questions popping in here. Wanyi, you're referring to the feature that reduces the power consumption. I think the main driver here is really that SoftSIM in itself is reaping the benefits of the architecture of the device itself. So with a SoftSIM, while we are reducing or removing, I should say, the hardware element of a SIM, the dedicated hardware element, we're really removing a lot of overhead from the you can say traditional architecture, and so that means that the SoftSIM is not reliant on any kind of SIM specific hardware architecture, which is really reducing the footprint of the idle mode power consumption here. Raphael, you're asking on the lifetime increase. So this will obviously depend on the use case, as use cases which sits with like very active transmitting use cases will sit proportionately less in these idle modes, and therefore probably reap less proportionately the benefits of that. These the setup where these oh, I get a little cue here. I should read out the questions before. That's probably a good idea. So, Raphael, your question is, how can lifetime increase 4 to 6 times, only reducing 50 microamps, when most of the micro amp range power consumption is on TRX and other processes on the device? For that, I think the conclusion here is that especially for the use cases that sit long time in these power save modes, will reap the biggest proportional benefit of these optimizations. These are typically various forms of trackers, meters, various infrastructure elements where it could be alarm systems that sort of boot up and transmit or listen and react on transmissions from the outside network. But more rarely than you can say any kind of other active surveillance solutions or anything like that. So typically these use cases are the more reactive use cases, or they are transmitting in a scarcer pattern. Then maybe Martin, one for you. Alf's question on relevancy for other aspects.
Yeah.
I don't know if
So Alf asked a question, is this only relevant for EDRX, extended DRX? We don't utilize EDRX, we only utilize power saving mode. What will be in it for us? We are now using our MFF2 eSIM chip. So for power saving mode, the modem usually shuts down the supply to the SIM card, the physical SIM card, automatically. I think this time limit is 2 minutes. So under 2 minutes, I guess you would see a benefit of using a SIM card using power saving mode. But as we've shown in our measurements and what we have found out, it's really in EDRX where you get the big benefit of using a SoftSIM.
Yeah. Then Jan Willem, you're asking, is there any indication on when SIMCOM modems will be able to use SoftSIMs? So SIMCOM is another announced partnership of ours that is in the works. We will be able to reach out to you directly on indications there, but that is definitely one of the next ones in line that we're working on. And if you're not already signed up, please sign up for the news on that. That would be very relevant, it seems. Good. I think. Let me just quickly browse through. Then last one, it seems, Florian, how much overhead does the SoftSIM add to the size of the firmware? Martin, is that one for you as well?
Yeah, I think I can answer it.
Otherwise, we'll surely be able to get back on that one. That is one where I think I will for sure need to ask a friend, but it's a very lean setup. That's for sure. As it's also a very obviously very constrained environment that we're operating in. But Florian will make sure to get back to you on that with a precise answer. Okay, I think that is close to the end here. With that, then I will say thank you a lot, Martin, for sharing these findings and teeing this up. This is surely very very. Oh, is there another question from Robert? Yeah, and then there's the plans for QuickTel. Robert asks if there are any plans for QuickTel BG95 and BG773. Yes, there is, and we'll also be able to share that along the way if you sign up for news, and we'll also be able to get back to you after this webinar. But with that, I think we should prepare to wrap it up. So thanks a lot for all the questions. Thank you to you, Martin. I think this is really the start of good things to come. I think we've covered really promising ground together, and I can't wait to see the solutions that this will enable. So thank you, Martin.
Thank you. It's been really good.
And thanks to everybody tuning in. We'll follow up after the webinar for all the comments and presentations, requests for that, and be sure to follow up with that. Thank you a lot. Have a good day.
You've been listening to Made for IoT. Never miss another episode by following us wherever you get your podcasts. For full transcripts and slides, visit the link in the show notes or onomondo.com.